Hello, hi everyone. Welcome to the Student the Brand. This is your Siva sir. Today I'm going to discuss about electric current. See, electric current, grade 12, grade 12 topic. Electric current or current electricity. Electric current. Electric current or current electricity. We can. So the flow of charge is known as electric current. The flow of charge. Here I am considering this is a conductor. This is a conductor. Charges are moving. Okay, so positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, like that. So charges are moving inside of the conductor, right? So if you're considering charges are moving inside of the conductor, okay. Now I equal to dq by dt. This is called instantaneous current. Instantaneous current. And I equal to q by t. So average current. Average current. Sir, what is meaning of these two terms? Instantaneous current and average current. So instantaneous current is nothing but normally I am moving on the road. Okay. Suppose I am standing. So not only this example, one more example you can take. So I was standing in the railway station. So high speed rail is okay. Just past your position. So like this. Suddenly at that position, where you are standing, so you observe the train movement. That particular time, so you can get to know speed of the train. Okay. And so if the object is moving like this, so at particular instant, the velocity of the object or acceleration of the object is known as instantaneous acceleration at particular instant, particular time. Okay. So here also dq by dt is the instantaneous current at particular time. So what the charge moving in the conductor? Okay. The flow of charge in the conductor at particular instant, that is called instantaneous. Coming to average current, I equal to q by t. So the net charge flowing through unit cross area per second. The net charge flowing through unit cross section area per second is called what is that? Average current. And here there are 3 points. Point number one. Okay. So the flow of charge can be obtained by multiplying current and time interval. And the flow of charge can be taken if the time is if the current is function of time. Okay. So then integral initial time and final time, then current dt. And third one, so the flow of charge can be obtained. By taking the area under IT graph. I hope it is very clear. Just check once. Okay. So I equal to q by t average current. I equal to dq by t instantaneous current. Flow of charge can be obtained. Flow of charge can be taken. Current and change in interval. And flow of charge taken if the current is with respect to time or function of time. If the current is in function of time, then flow of charge can be taken. So T initial, T final up to dt, and flow of charge can be obtained by the area under IT graph, current and time graph. Okay, so right now, so based on magnitude and direction, current can be divided into two types. Based on magnitude and direction, current can be divided into two parts. Okay, based on magnitude and direction. Magnitude and direction. Based on magnitude and direction, current can be divided into two parts. One is DC, second one is AC. One is DC, another one is AC. So DC is nothing but direct current. DC is nothing but direct current. Okay. So direct current. Example, cell, battery. We can take cell or battery. Cell, battery, DC dynamo example. Okay. Cell, DC, cell we can take, cell, battery, and cell, battery, and DC dynamo. Coming to alternative current, coming to AC. Okay, alternate current, AC dynamo. So here both magnitude and direction changes. Understood? So DC is nothing but direct current. So magnitude and direction does not changes. DC magnitude and direction of current does not change. AC both magnitude and direction changes. Example for DC, cell, battery, DC dynamo. Example for AC, AC dynamo. Okay, right? Now, if the charge is moving in a circular path with frequency, so I am taking this as charge. This is the charge. So charge is moving. Q is moving in a circular path with the frequency. So then current can be taken Q into F. Okay, if the charge is moving in a circular path with the frequency, F, then current can be taken as, so I equal to QF. Okay, now current and drift velocity. So drift velocity we'll discuss. So drift velocity. Okay, so drift velocity. So what is drift velocity? Okay. Normally, if the current is flowing in the conductor, there is electrical field. If charges are moving in the conductor, there is electrical field. Yes, sir. Right. So positive charges are moving along. So current direction will be taken along the positive charges movement direction, or positive charges moving direction. And the electrical field also we are taking in the same direction. Then what about Electrons. Electrons will move opposite to the electrical field. Electrons will move opposite to the electrical field, right? Yes. So I'm considering here you can observe. So current is flowing I and electrical field is there. So I'm taking the velocity electrons. So electrons are moving in a particular direction opposite to the electrical field. Opposite to the electrical field. Yes or no? Opposite to the electrical field. So I hope it is very clear. So that's enough. Opposite to electrical field, electrons are moving. Okay. If the electrons are moving, so anyway, number of electrons if you take, they'll move in different directions. Number of electrons. Okay. So I'm considering only one electron. So so my intention is to represent electron is moving opposite to the electrical field. That's enough. You can take many number of electrons. So not only 1, 2, 3, 4, like that many you can take, no problem. So their directions also different. I will explain. Where I'm explaining drift velocity, that I will explain. So before that, we are discussing current is, okay, current will be taken in one direction, electrical field will be taken on the same direction. Electrons will move opposite to the electrical field. Electrons will move opposite to the electrical field. Now, so now you can observe here. So force will act on electrons because it's moving opposite to the electrical field, right? Okay, electron is moving opposite to the electrical field. So definitely force will act. Force will act, right? Yes. Now, that is E into electrical field and F equal to Q into electrical field. So we know F equal to ma. Force equal to mass into acceleration. Now, so ma equal to Q into E. Then A equal to Q into E by M. Okay. So that is the acceleration. That is the acceleration. Sorry, here drift velocity we are discussing, right? So that is acceleration. So movement you can take. So along the direction of electrical field only will be the acceleration. But what about electrons? Electrons are moving in the conductor opposite to the electrical field. Okay, charges are moving, positive charges are moving this direction, electrons are moving opposite direction. That is okay. Fine, agree. Now, if the electrons are moving in a closed path, all electron, not only one, there are many electrons are moving in the conductor in a closed path in one direction. Okay, so electrons are moving one direction. So this one electron, here you can observe, this one electron, this one electron. So they are moving in a bit same direction like this. So what happens? And one more electron also there like here. So they are moving in a closed path. Okay. Then this electron will hit this electron. It will move like this. And after hitting, this will go to the another electron that will hit. After that, keep on, collision will take place. Initially, this has some velocity, right? So it's moving like this. After collision, this one is moving with some velocity. After that, so the velocity of the electrons are changing. Initially, they are moving with a different velocity. After collision, the velocity will change, right? Yes or no? Velocity will change. So compared to previous one, after collision, velocity will change. The average velocity of an electron moving in the conductor. The average velocity. Okay. So like you can observe in the class. So one person got 20 marks, another person got 30 marks, another person got 60 marks, or some other person got 70 marks. If you calculate average, some 45 like this something, or rough idea, like that. So average if you take, average. 45, 50, like that. You'll get a 55, something. Okay, rough idea. Average if you take, add all the things and divided by total number of students. Then you'll get average. Yes or no? So here also electrons are moving with different velocity. One electron is moving with one electron's velocity, another one electron is moving with velocity. This also will move, so moving with another velocity. So what happens? They are moving with a different velocity. After collision, the velocity will change. Okay, after collision also velocity changes. So if you take the average velocity of an electron moving in a conductor is called drift velocity. Drift velocity. Okay, so I hope it is very clear. The average velocity of an electron, that is constant for particular whatever it is moving, the electron is moving in the conductor. And coming to the relaxation time. Relaxation time. Relaxation time. Okay. Relaxation time. So what is relaxation time? So as I said, one electron is hitting another electron. This electron is hitting another electron. After collisions, there is a time gap between one collision to another collision. So after hitting, immediately it won't go, right? Immediately it will take certain time to reach to the next electron. After collision, again it will reach to the another electron. It will take certain time to reach next collision. The time gap between two successive collisions. Sir, we can take the time gap between one collision to 20th collision, one collision to 30th collision, one collision to 56th collision. No, not like that. The average time gap between two successive collisions. Successive collision in the sense, one after another. One collision happened just now. Immediately going to the another collision. So the time gap between the two successive collisions is known as the average time gap between two successive collisions is known as relaxation time. So, sir, here how you are saying average time? So here is collision is not happening only one time. So one time is done, your work is done. So you don't hit another electron, you go in a straight path. Will electron will move like that? No, it won't happen. After hitting another electron, another electron, another electron. Because they are moving in a closed path. One target you reached. Will you stop there? You have to reach to the next target. Next target. It continues. Same here also. After hitting, after colliding one collision, it will goes to the another collision. Because they are moving in a same direction. They are moving in the same direction. One direction. One electron will hit another electron, another electron will hit another electron. The electron like that keep on collisions, keep on bombardment takes place. That's enough. So the average time gap between one collision to another collision or between two successive collisions is known as relaxation time. I hope it is very clear to you, right? Yes. So that is about drift velocity and relaxation time. Now we'll discuss about drift velocity and current. Drift velocity and current. So we'll keep it like that, drift velocity and current. Sir, here we are taking cylindrical conductor. Like a current is flowing in the conductor. Right? So now I am taking here like this. So this area of the cross section. Area of the cross section denote with A. Here also area of the cross section denote with B. Okay. Here area of the cross section. Here also area of the cross section. And current is flowing and electrical field is there. So from here to here I am taking and electron is moving. So that is a drift velocity. So VD. V suffix D. Okay, so we should not write beside. So we have to take V D like this. Okay. Now time gap, right? So from here to, if the electron is started here and moving to until here, so there is a time. It's not like a flash like this it goes. Okay. So just if you observe in a closed, right? So electron will start from here to here, right? Okay. Just in a closed manner we are discussing. Okay. If you observe in closed manner, electron is started here and moving here. So this time gap will be there, right? Time gap. Yes or no? So now we know velocity equal to displacement by time taken from this formula. Vd equal to L by delta t. So length equal to length of the this from A to B, or you can take, or C to D, or XY, anything we can take. L equal to Vd into delta t. That is the length. Now what about volume? Volume formula. Volume formula. V equal to length into area. Is it correct? Volume equal to length into area. Is it true or false? Yes, it is true. Volume equal to length into area. Correct. Okay, done. So now we can take volume equal to length. We know what is the length? This one. Length into area. Volume equal to length means Vd into delta T into A. Okay. So only one electron is not moving, right? In the conductor. Or two electrons also not moving. Many number of electrons are moving. So number of electrons are moving in the particular area of the cross section. There is nothing but a volume. But in this particular volume, how many electrons are moving? How many electrons are going? That is number of electrons. Number of electrons. That is N into Vd into delta into A. Now we know quantization of charge N into E. So this is total number of electrons I am taking. Then Q delta Q equal to, so instead of, because no need to get confused, you can consider number of electrons. You can write number of electrons into E. Now same I am taking here. So delta Q equal to, so N Vd delta T into A into E. Same number of electrons. This is the total number of electrons present in a particular volume. Then N into Vd into delta T into A, that is C. Now we know current. Current equal to delta Q by delta T. So now N Vd delta T into A E by delta T. So delta T get cancelled. Yes or no? Then what is the value? I equal to NE Vd A. Sir, I have one doubt. What is that? What is current density? Current density is nothing but current by area of the cross section. Okay, so current density equal to, so J, current density can be denoted with the letter J. So J equal to I by A. What is I? N E V D into A by A. A get cancelled. So J equal to N E V D. This is the answer. Okay. So drift velocity and current density. Already, so drift velocity we discussed. So relation. So relation also we can take, relation between current and drift velocity. So I hope it is very clear to you all. Okay, check once. Now we will discuss about resistance. So actually it will take nearly 1.5 hours. So if you discuss everything in detail, but we do our level best to discuss. Now resistance. Resistance is nothing but here 3 points I will discuss. Point number 1, resistance. Point number 1, resistance, and point number 2, resistor, and point number 3, ohm, and so we can take that is symbol, this is ohm. So resistance, sir, what is the meaning of resistance? Resistance is nothing but phenomena of opposing the electric current. Resistance is nothing but phenomena of opposing the electric current. What is resistor? Resistor is a device which is used to oppose electric current in the circuit. Resistor is a device which is used to oppose electric current in the circuit. Resistance is the phenomena. So there is a much difference, huge difference. Resistance is the phenomena of opposing the electric current in the circuit. Resistor is a device which is used to oppose electric current in the circuit. And coming to SI unit of resistance, ohm. So SI unit of resistance is ohm and symbol is this one. And coming to the resistance is depends on length of the conductor. If length is more resistance. If length is less resistance. And area of the cross section. So if more area of the cross section, less resistance will be there. If less area of the cross section, more resistance will be there. Inversely proportional. One physical quantity increases, another physical quantity decreases. One physical quantity increases, another physical quantity decreases. So opposite. One up, another one down. Another one up, this one down, like this. So inversely proportional. Okay, and so R is directly proportional to L by A, and R equal to rho into L by A. Sir, here what is rho? The new term. R equal to rho into L by A. Rho is nothing but resistivity. Rho is nothing but resistivity. Now we will discuss the difference between resistance and resistivity. Resistance and resistivity. Okay, resistivity. So R equal to rho into L by A. Here rho equal to RA by L. And coming to the second one, so SI unit of resistance is ohm, symbol. SI unit of resistivity is ohm meter. So here this one we have to derive. So here you can observe from this rho equal to RA by L. So R equal to rho into L by A, right? Here R equal to rho into L by A, rho equal to RA by L. Now SI unit of resistance is ohm, SI unit of resistivity is meter, SI unit of length is, so SI unit of area is meter square, SI unit of length is meter, so meter get cancelled, then Ohm meter. So SI unit of resistivity is ohm meter. Very, very important. SI unit of resistivity is ohm meter. I hope it is very clear. Right? Yes. Now resistance. Third one. Resistance is depends on temperature, and here resistivity depends on temperature. And coming to the fourth one, resistance depends on material of the conductor, and resistivity depends on material of the conductor. So here you need to understand one thing. So identify the differences. Okay, similar ones is, so you can check these are two similar ones here and there, and these two are different. Okay, and here one more point is resistance depends on length and area, but here resistivity does not depend on length and area. So that is nothing but physical dimensions. We can say physical dimensions. Resistivity does not depend on physical dimensions. Resistance depends on length and area. That is nothing but physical dimensions. Okay. Now we can discuss one more. Temperature dependence of resistance. Temperature dependence of resistance. Temperature dependence of resistance. Here temperature dependence of resistance, and we can also take resistivity also. So here I will tell 2 points. Point number 1. So this is the conductor. So here you can take, if you increases the temperature, if you increase the temperature of the conductor, so the free electrons in the conductor will increase, or movement of the electrons will be more. Automatically electrons will move more faster. So 2 points very closely observe. Point number 1, when temperature increases, movement of the electrons increases. Okay, so electrons will vibrate with a greater amplitude. So as I said, in drift velocity, electron will go and hit another electron, that electron will go into another electron, that electron will go into another electron. Electron will not stop until it reaches the destination. Still it continues the process. There is a comma, no full stop. Yes, sir. Until you remove the battery or you off the switch. So it's keep on. Okay, so electrons keep on moving like that. And here the point is, when temperature increases, electrons will move with a more greater amplitude. By that what we can understand generally, resistance and resistivity decreases, conductivity increases. Conductivity increases. So okay, sir, everything is good. You said when temperature increases, electron will move with more faster, with greater amplitude. Oh my god, so many great words, big words, lengthy words. We can understand. That is good. But how resistance and resistivity increases when temperature increases? That I will tell. I said 2 points I will discuss. Point number 1, as soon as temperature increases, electron will move with greater amplitude, more faster. So in that time, resistivity and resistance decreases, conductivity increases. So if the electrons are moving with greater amplitude, more faster, then what happens? The electrons start colliding with another electron. This electron will collide with another electron. That electron will collide with another electron. Then keep on collision will take place, keep on bombardment takes place. Then by that time, so number of collisions, more frequently collisions will take place. More collisions will take place. Then what happens? What happens, you tell me? That time electrons will move in that particular area only. Collisions will take place, keep on, it won't move forward. Then resistance and resistivity increases. Now you can understand, when temperature increases, resistance and resistivity of the conductor increases. If temperature increases, conductivity decreases. Conductivity decreases, resistance and resistivity increases. Understood? Now you can observe. So R naught is at temperature T naught, R equal to T, and even rho E naught equal to temperature T naught, rho equal to T. Now R equal to R naught into 1 plus alpha into T minus T naught. Now you can take R minus R equal to R naught plus R naught into alpha T minus T naught. Then you can take R minus R naught equal to R naught into alpha into T minus T naught. Then alpha equal to R minus R naught by R naught into T minus T naught. So this is the temperature. Alpha is the temperature coefficient of resistance. So as we know, R is directly proportional to length of the conductor, R is inversely proportional to area of the cross section. R is directly proportional to L by A, R equal to rho into L by A. So as temperature increases, length and area also increases, that is small. Then R is directly proportional to rho. Then so rho equal to, so alpha equal to, so we'll write alpha is also temperature coefficient of resistivity. Alpha equal to rho minus rho naught by rho naught into T minus T naught. I hope it is very clear. Now check once. Understood? Okay. Now, electromotive force, EMF. Electromotive force, EMF will discuss. Sir, what is EMF? Electron is moving in the conductor, it experiences some resistance. It is moving in electrolyte, so it experiences some resistance, that is called internal resistance. Internal resistance. Sir, why you are saying all these things? So normally you can take this a battery, so connected to resistance or resistor, current is flowing, positive terminal, negative terminal, and high potential and low potential. High potential and low potential. Here is high potential, low potential, so current is flowing like. Okay. EMF. We are discussing now EMF. EMF. Sir, what is EMF? Electromotive force. So, what is the meaning of it? Normally, when cell or battery is connected to the circuit, current is start flowing. So positive charges will move from high potential to low potential easily. Positive charge, whenever you connect a cell or battery, positive charges will move from positive terminal to negative terminal very easily. Okay. Electrons also will move from low potential to high potential. So if now charges are moving from positive terminal to negative terminal, again it is reached. Inside of the battery, from negative terminal to positive terminal, the positive charges should move. So how they will move? How positive charges will move from negative terminal to positive terminal in the cell? The influence that makes the positive charge to move from negative terminal to positive terminal, the influence are work done by the cell, or work done by the battery, or work done by the cell to move the positive charge from negative terminal to positive terminal is called electromotive force. Electromotive force, EMF. E equal to, denoted with E equal to W by Q. So Q is the positive charge moving from negative terminal to positive terminal of the cell. Q is a positive charge. So 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge from negative terminal to positive terminal. Next, resistors are connected in series combination. Resistors are connected in parallel combination. We'll discuss those points. Resistors are connected in series combination. Resistors are connected in parallel combination. Okay, so we'll discuss that point. So let's start. So if resistors are connected in series combination, so now I am considering here. So 1, 2, 3. So R1, R2, R3. So current is passing. So battery, cell. So positive terminal, negative terminal, current is flowing like this. So across R1, V1 is there. So across R1, V1, across R2, V2, across R3, V3. Across R1, R2 and R3. Across R1 is V1. Across R3 is V2. Across R2. Across R3 is V3. Okay, so current is flowing like this. I, and here also I. So entire the circuit, current is same. Throughout the circuit, current is same. Yes or no? So Is equal to I1 equal to I2 equal to I3 equal to I. Current is same. But potential difference is different. Potential difference is different. Right? Now, so Vs equal to V1 plus V2 plus V3. Vs equal to V1 plus V2 plus V3. That is nothing but IRs equal to IR1 plus IR2 plus IR3. So shall I take I common? So if I take I common, then so what you will get? Is it clear? So now I am taking I common. I, if you are taking common, IRS equal to I, you can take common R1 plus R2 plus R3. So I get cancelled. I get cancelled. The answer RS equal to R1 plus R2 plus R3. RS equal to R1 plus R2 plus R3. Understood? So throughout the circuit, current is same, potential difference is different. R1 across R1 V1, across R2 V2, across R3 V3. IS equal to I1, I equal to I2 equal to I3 equal to I. So by that we can take, so Vs equal to V1 plus V2 plus V3, IRS equal to IR1 plus IR2 plus IR3. IRS equal to I common, R1 plus R2 plus R3, IA get cancelled. RS equal to R1 plus R2 plus R3. Okay. So resistors are connected in series combination here. Now resistors are connected in parallel combination. Resistors are connected in parallel combination. We'll discuss now. Resistors are connected in parallel combination. Now you can observe here. So current is dividing, but potential difference is same. So Vp equal to V1 equal to V2 equal to V3 equal to V. Because potential difference is same. Current is dividing, right? Now in that case, so Ip equal to I1 plus I1 plus I2 plus I3. Then V by Rp equal to V by Rp equal to V by R1 plus V by R2 plus V by R3. So now we can take V common. V I am taking common. So V, if you take common, 1 by R1 plus 1 by R2 plus 1 by R3. So V we get cancelled. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula. Okay. So if resistors are connected in parallel combination, you can observe here. So R1, R2, R3, I1, I2, I3, through R1, I1, through R2, I2, through R3, I3. So resistors are connected in parallel combination. Okay. Then current is different because different current. So current is dividing into three parts because I connected here 3 resistors. If you connect number of resistors, it depends. Okay, so current will be divided. So Vp equal to V1 equal to V2 equal to V3 equal to V because current potential difference is same across 3 resistors. So Ip equal to I1 plus I2 plus I3. So V by Rp equal to V by R1 plus V by R2 plus V by R3. So V by Rp equal to V comma V we get cancelled. 1 by Rp equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula. If n number of resistors are connected in parallel combination, 1 by Rp equal to n by R. 1 by Rp n by R. So this is the formula. Okay. So resistors are connected in parallel combination. I hope it is very clear. Check. Okay, so few more topics are there, like Kirchhoff's laws, heating effect of electric current, and grouping of cells. So nearly it will take 40 minutes to 1 hour. In the next class, I'll discuss these points. If you like the content, if you like the explanation, if you like the channel, so please do like, share, and subscribe to Studying the Brand. Please do support. Okay, so I'll come with a great content. So soon we'll start the test series. So you'll get the best content in the channel. So if you like the content, if you like the explanation, do like, share, and subscribe to Studying the Brand. And if you like the channel, you can share your friends, ask your friends to join to the class. Thank you so much. This is your Shiva sir from Studying the Brand. Thank you.